Okay, so let's do that. So what we're going to do here is we're going to design a database structure, a simple database structure for a Lego store. Okay,
Okay.
so let me go ahead and share out my screen so we get my Excel going here. Okay, so let's kind of like go over like we're gonna need a customers table, right? Right.
Customer.
So we want a table to keep track of our customers in. We're gonna want an employees table, right? What other tables do you think we might need? Just
Maybe like
generalization.
a product ID, maybe
Well,
order
just a products table. We need a products table.
product.
Okay. An orders table. Okay. What else might we need? We're gonna want to. I don't know what would we call this. We call it sets. We call it
Would
themes.
you put brands or things?
Well, we're
Yeah,
just doing Legos, so it's gonna be all Legos brands. However, like you said, there's
themes.
Star Wars Legos, there's Indiana Jones Legos. So what would there be? What not genre? That wouldn't be the right word for it.
A
Fandom would be a
category.
category. Let's call it category. Sure, category. Category. Okay. What else do we need? So we're selling Legos. We need to know the products. They'll have a category.
Oh, the price maybe.
That would be in the products table.
Oh,
That'd be in the
okay.
products table. So we're trying to think of like what. So we're looking at when you're designing a database, the first thing you do, your first pass is the broad things like the customers, the employees, the products, the orders, the categories, and let's put down. I just had it payment. How people are going to pay you.
Oh, okay. So like, which
Right.
type of credit card or
Right. Well, it's not credit
cash?
card, cash, store credit, gift card, any number of those things. So I think that's good. So that's 1, 2, 3. That's 6 tables. This will blow up to quite a few tables in the very near future. So let's go ahead and make our first table. Make the customers table first. Okay. So we know we'll need customer ID because we need that every single time, right? So what else would we need for a customers table?
See, maybe their first and last name,
Mm-hmm.
their address, maybe.
No, absolutely. Address, yep.
Do you ever put like email address or no?
Email address, yep. So now with address, we have address, then a city, state, and zip. And then email. Absolutely. What else might we need of them?
Their order history, maybe.
That's gonna be somewhere else. Because remember, so when we look at a table, what's inside of a table, we want only things that are directly related to the topic of that table. So order history is not related to customer as much as it's related to order. Okay. So what else about the customer might we need to know? I can think of 2 other things that we might want to know about them.
How?
Phone number.
Phone number.
Yep. And I think birthday.
Oh, their age. Okay.
No, see, here's
Birthday.
the funny thing. Just as a you understand, you cannot ask someone their age, but you can ask them what their birthday is.
Oh, okay.
It's
different.
sneaky.
It's a
It
different.
is. Because if you ask my birthday, I'd either say March 25th or March 25th, 1970, right? So I'm volunteering the information. You're not asking for it. Okay. So I think that is a good. Let me bold this out here. I'll send this to you when we're done. Okay. Pull that out, and let me go ahead and I want to do a little formatting here for fun. I want a fun format. Okay. So format that way. Okay. So now let's look at an employees table. Okay. Also, just as a sidebar, we never pluralize table names. It's always employee or customer. I mean, you can. It's an unwritten rule, but just Okay, so let me get here. That's what I want here. Okay, so
It's kind of implied
yep.
by.
So what would we want to know about our employee?
Um, did they need an ID as well?
Everything starts with an ID, and
Okay.
we need the first name and last name too. Address, city, state, zip, sure.
Do you put like what role they have or?
Okay, so what is their job? Okay, so we'll do job here. We won't call it position. Just call it job. Okay.
And
We probably want their email and phone number too.
okay. Do you put their birthday as well?
Sure. And we probably would want their social security number.
Oh, for taxes. Okay.
Okay, so I think that's good. I'll do that. Yes.
Now, do most companies do they have like a table for W-2s as well?
So that's it. So that's an interesting question. So there is no table for W-2s. What there would be, and we'll look at that in a second here. So what there would be the information would be stored in the databases, but there wouldn't be a table specifically for it. So they'd run a query off of they'd run a query to get that information out. For example, we're not going to when we get to the orders table in a second, we're not going to like have in there like we won't have it specifically stated in there like how many of a specific set of Legos were sold, but that information in the database we just have to write a query to get it out.
Okay.
Okay, so we'll look at that in a second. Okay, so we got employee ID, customer. So let's look at our products table. That'll be next, right? So let's do products. All right. So what do we need to know about? So we need product ID.
Do you have like the, let's say, like the product number?
Okay, product number, sure. We'll call it model number.
Model number. Okay.
What else?
Do you put a UPC number or is that different?
UPC is different, sure. UPC, absolutely. What else?
Maybe it's price.
Price.
I think for Legos, maybe the number of pieces, I guess.
I think that's important. Okay.
And is this where you put like category or no?
Sure, category.
Okay.
Okay. I think we're missing one very important thing.
Oh, it's name?
It's name. Okay.
Yeah.
So we've got product ID, name, model number, UPC, price, number of pieces, and category.
And would you ever put like frequently bought together with, or you know?
That would again be a query written off of something else.
Oh, so
Because
most
everything
things
of
are queries.
Yes. Remember, the tables only hold data that are pertinent to that topic. So only put things that are important to the product in there, right? So often bought with would be in the orders table, and it wouldn't be a setting in the order table. It'd be a query we could write off the orders table. Okay.
Okay.
I think the other thing would be retired.
Retired. Oh, if it's still sold.
Yeah. Now we're not talking about data types here, so you're going to have to figure out the data types on your own. How that's going to work. Okay. So that's something else. Okay, so let's go here. What the table is. Okay.
So are there only 3 types, just temporal data, string, and then number? I know there's more.
No, there's numbers are int, big int, small int, huge int, decimal, long, depending on what you want. It all depends. And I think I posted the data types lecture earlier in the semester. It depends on like there's a price. So there's specifically one that's price. So it'll be the cost, or it's called money or price, for which one it is in MySQL. So you int and things like that. You like, for example, your model number would probably be a char because there's probably numbers in it. But your price, so number of pieces would be the only thing that'd be guaranteed to be a number because it's an actual number, right? So yeah. Okay, so we got that one. Let's do orders. Let's hold on. Let's do the category first. Okay. Category table. So a new table here, category.
Now with something like category, would you put how many times like they did revisions, or I mean waves, I guess?
Every new wave would have a different model number.
Okay. So it doesn't matter.
Right. So you might have a number of products that have the same name, but they probably have a different model number and definitely have a different UPC.
Okay.
So Hagrid's Castle for the Harry Potter collection has been revised 7 times, 7 editions of it. So each one would have a different barcode, each one would have a different model number, but they would definitely differentiate in there. So under category, so category and category name. Anything else about category other than would fall in there? Just those 2 things? Anything else you can think of?
Maybe the number of products, or is that?
No, that would that'd be a query. How many products under the category? So we'd write the query on the products table and the category table. We'll get to that in a second, but yeah, that wouldn't be something recorded there.
Yeah.
Anything. So anything. So a good rule of thumb is anything that's calculated would be a query. So whenever you say like how many or how much, it would be a query, not a column. Does that make sense?
Okay, that makes sense.
Okay. So I think that's it. We can always revisit these and add columns to them if we need them. Let's make that a table. Okay. And then we'll do payment over here. And payments can be the same thing. It's going to be payment ID and then type. So you need to know credit card, cash, blah, blah, blah. We would not keep credit card numbers or bank account numbers or anything like that. So that is all that needs there. Okay. Before we get to the orders table, because that'll be a little bit fun, let's look at what we got here. So we have here a category, right? Is there a way to draw? I can't draw. Oh, good. Okay. So first of all, let's look at what are our primary keys going to be. So in customer table, it's going to be our primary key.
The primary key?
Yeah, the one that everything's going to be searched off of.
I think customer ID.
Yep, okay. And then what about, go do this, is fine. What about employee?
The ID as well.
Okay. So it's safe to say that everything that's an ID is going to be that. Okay, so part of it.
Okay.
Okay. Oops. Okay, so let me do this, and do that. Okay. And then change that to PKL. And let me insert row here because we're getting insert. Okay, that's good. And get rid of that. No, I don't want to do that. So, okay, that's fine. Okay. Okay, this will be the primary key too. So let's look at here. We got customer ID, first name, last name, address, city, state, zip, email, phone number. They got company email, employee ID, first name, last name, address, city, state, zip, email, phone number. Okay, good. Okay, so now here we got category here, but we got a category table. So we want to, we want to simplify things. So one of the reasons why we put join tables together is, well, the only reason why we join tables, well, one of the reasons we join the tables together is for pureness of data. We want the data to stay as pure as possible. And the number one way to make sure data is impure is when we let people touch it. Okay? So we're thinking in terms of there's going to be some kind of front end to this where people are going to be inputting products and information, right? So we want to make it as simple as possible. So we probably want a drop-down menu for them to populate the category of the Legos, right? So that means we need to link the products table and the categories table so that nothing can exist here if it doesn't exist here, right? We want to make sure that every category is legit. Does that make sense?
Yeah.
Okay. So we're going to go ahead and draw a foreign key. And now that I can do this, because this is going to be fun now, I can do this. We're going to do a foreign key. Oh, it's not letting me draw this. Why you let me draw before? Okay, there's that. Good. Okay. I don't want that thick.
Oh, and then when they run queries, those are temporary tables. It doesn't actually touch the data, correct?
So yes, it's not necessarily temporary tables, but whenever data is brought out and reviewed in a select statement, it's brought into memory, and that's where everything happens.
Oh, okay.
Okay.
So you can modify content.
Absolutely. Okay, so this is going to be a foreign key, and we're going to change this to category ID. Okay. Do you follow that?
Yeah.
Okay. So we're going to do the orders table now, because this is where it's going to be a little bit on the complicated side. We're 5 tables in of 12, so we gotta make 7 more tables after this one. So the orders table. So what needs to be in the order table?
See the order ID. It also needs to include like which products, right? Is that just product?
Okay. Yep. What else needs to be in the order table?
Is it payment maybe? Oh, and then customer.
Okay.
And then would you put the employee who was using the cash register?
We want to keep track on who did it. Yep, absolutely.
Oh, and do you include the category of the product? No, I don't think so. I think that's all.
Okay. So, well, because we're going to link these tables in somehow, if we link this table, that table will be linked to it. So it's all about how data flows, right? Okay.
Yeah.
So let's say order ID is so product ID. So let's do customer first. Okay. We don't want to put in the customer information all over again, name, address, and phone number, right? So we just want customer ID. And we're going to foreign key it back to the customer table. Okay?
Okay.
We're going to do the same thing with employee. And we're going to foreign key it back to the employees table, right? So now product. Well, payments, right? Payments there. Okay. Okay, payment ID, obviously. Now product. This does render a bit of a problem. Okay? Because we're going to assume that one person will buy multiple things on one order. They're not going to come in and buy one thing at a time, right?
Okay.
So we can't, one of the rules of normalization is I can't have like product 1, product 2, product 3, product 4 in the orders table because A, I don't know how many things they're going to buy. And B, if they only buy one, I've got like 3 or 4 null columns and we don't like that, right? So what we're going to have to do is we're going to have to make a separate table and we'll call it product orders. Put it here.
Wait, so does that mean that a lot of times like say someone like Amazon, they expect people to buy more than one
Well,
thing.
we're not expecting. We're just planning, right? Because
Oh,
we want to keep track of everything, right? So I can't do product 1, product 2, product 3, product 4 here. I've got to have a separate table, right? So we do right here. We'll call it product orders. Call it prod order,
yeah.
right? Set to that. Okay. Oh, I see. Okay. It's here. Okay. So I'm gonna do prod orders. And in here is going to be a prod order ID. Actually, no. I'm going to have product ID. And I'm going to have order ID. Yeah, order ID. And then I'm going to make these two columns the primary key. Hang on 1 second, I gotta answer the door. Okay, so you can have multiple columns be a primary key, right? Because in a primary key, this column has to be unique. Okay, there can be no duplicate entry into the ID columns. When you do multiple columns as primary keys, okay, these two columns have to be unique together, not separately. Does that make sense?
So they're together, they're unique.
So here, like here, I can have 1, 2, 3, 4. I can never duplicate 1 or 2 or 3. Here, I can have like my data could look like this. It'd be like 1, 2, 1, 4, and the combination of the two columns have to be unique. Okay, not the actual just one column. So we have this, and this will be our per order table. Go ahead and do this here. Okay, and we're going to foreign key these out. So now notice we don't have the product ID in the order table. It's just over here, and these tables are going to all link this way. Okay, so let me draw those. Let me draw those foreign keys here for you, so you can kind of see them. Okay.
So the combination, like, as long as they're not the same, like 1 and 1, or like
Yep.
2 and 2, it's fine.
Yep. Okay. So I go ahead and do this. Okay. So now let me get my little marker here. Draw. Okay. So what I want to do is I'm going to do picture. Okay. So I have oh, I didn't do this yet. Hang on a second. I don't really want to do that yet. Okay, so I'm going to do this. So I'm going to foreign key this to here. I'm going to foreign key this to here. I'm going to foreign key this to over here. And I foreign key that to that. And I foreign key that to that. Okay? Does that make sense?
Yeah, that does.
Okay. So 2, 3, 4, 5, 6. So we're at 7 tables here. And we need to make 5 more. So one thing we can look at here, and we're going to talk about the other tables that we can design. I'm going to leave them for you to design, okay? And put them in here.
Yeah.
So do you have any questions on what this has been done so far?
Well, okay, so to connect a table to another one, you can just put it as the primary key as a foreign key.
Yep.
In the new table.
Yep.
Okay.
So we're connecting. So the products table category is connected to products through the category ID table, right? The products is connected to product order by the product ID column, and so on and so forth. I'm going to make one other table here, and then I'll leave 4 for you to do because I want to make one point here. I'm going to make a table called, I'm going to get my typing thing back here. Okay, and I'm going to do a table called zip code.
Zip code.
And it's going to zip, city, and states. Okay. Now, one of the other things we do in normalization is we want to reduce the amount of data that's repeated across databases, across tables as well, right? So here I've got city, state, and zip, and here I've got city, state, and zip. It'll be the same information across the board. So what I'm going to do is I'm going to get rid of these 2 columns. I'm going to get rid of these 2 columns, which is going to screw up my drawing, but I'll fix that. I should have done that before.
But you wouldn't want to put address with it as well. It just
no, not address, not address, but we would just do zip, because city, state, and zip, that's the same across the board. Only one person's going to live at that address, right?
Okay. That makes sense.
Yeah. So
because those are usually related.
Correct.
Zip is equivalent to the city and state.
Yep. And I fixed my lines. See, hey, look at my lines. Okay, so what I'm going to do is I am now going to foreign key that to there and that to there. Okay.
Okay.
So that gives us 3, 5, 6, 4. We need 4 more tables. So what other things do we need to do in here? We've got
do you put like shipment?
Okay, that's a good one. If they were shipped or not. So where would you? So how would you do that? So you'd have a shipping table, and what would that shipping table have in it?
Shipping ID.
Uh-huh.
Maybe the carrier. Or
okay.
And maybe date when it was shipped, and then expected time of delivery as well.
Okay, sure. And then how would you? So that would work. So shipping ID. Well, I know the shipping table would be who does the shipping.
Oh, okay.
So it would be the shipper ID, the name of the shipper, probably their address, and probably like a contact number and stuff like that. So how would you track how the orders were shipped?
Would you create another table for each of those?
You absolutely would. You create an orders shipped table, and in there would be what? The order ID and the shipper ID, and then all the other things you talked about: date of shipment, cost, right?
Okay.
Okay.
Weight, maybe.
Weight. That's that's an interesting thing. Yeah. So what you would have to do if you're doing shipping, you'd actually have to add weight here to your product, because that would have to be a calculated thing. You'd have to calculate how much weight it is for shipping. You need that information in the database. You need the weight there. So, but in the shipped order, you would have. So in the shipped orders, you would have a weight column that would be calculated.
Okay.
So basically, when you input the data into the shipped order table, you'd have to get the sum of the weight from the products table in what was ordered.
Okay, and then
this is getting complicated. So let's back off a little bit. Let's back up. So right now, you've got 2 more tables that you need to create on your own. I'll put their names over here. So you want to create a shipper table. and you want to create an order shipped table. Okay, and the shipper table with the shipper information, and the order shipped would be how the orders were shipped, when, their date, when they were received, things like that. Yep, tracking number.
Okay, one thing that's kind of confusing, and it's more in like the last couple years, but one thing that's really confusing is online sales tax, because is that always the customer that pays that, or the company just, I don't know.
So I'll explain it, but let's not include that in this design.
Oh, okay, don't include it.
Yeah, let's not include that in this design, because it gets complicated. There's a lot of, we don't want to like, go crazy with this. So what the sales tax is, if the company has a physical location in the state that you are in, then they have to charge sales tax. So if you're in Alaska, right?
Yeah.
Okay, we're in Alaska. I love Alaska.
Let's see, Wasilla.
I know Anchorage. I know the big.
It's near Anchorage.
Okay, yeah, I was there a couple years ago. I loved it. I was there actually on the longest day of the year. Is it still mostly dark right now for you?
Yeah.
Yeah. So let's say you're running a Lego store out of Anchorage, Alaska, and it's just you, it's your shop, you sell your stuff, blah 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 blah. Okay, you only charge sales tax to anyone who buys your products in Alaska. If I buy something from you in Florida, I don't pay sales tax.
Oh.
Because they haven't. I don't know if Florida hasn't done it. I've heard rumors of other states doing it, that even if you sell something internationally, if you sell something even out of state, you still have to charge sales tax. But generally speaking, if I in Florida buy something from you in Alaska, or you in Alaska buy something from me in Florida, there is no sales tax on it. Amazon charges sales tax on pretty much everything, because Amazon is everywhere. It's in every state.
Okay.
Yeah. With the warehouse thing, I don't know if Alaska, but like Florida's like 4 Amazon warehouses.
Oh, really?
Yep.
I didn't know that.
That's how you do same day. Same day delivery. The stuff that's in that warehouse, they can do same day. Okay, so we've got shipper table, and we've got the order ship table. So what other tables do we need? We got 1, 2, 3, 4, 5, 6, 7, 3, 5. Oh, wait, 1, 2, 3, 4, 5, 6, 7. Oh, that's there's 10. So we need 2 more. We want to do 12. Customer ID, employee ID, zip code, or ID.
Wait, 3 more? Wait. Actually, oh no, that is. Okay, yeah, 2 more. Maybe there would be.
Oh, I know one that we forgot. The job table.
Oh, job table.
Because we got a job here, and we don't want to, again, the same reason, we could have just put the category in here, like written Harry Potter, Star Trek, Star Wars, whatever, but we want to put it in a separate table, because we want to have consistency. So someone doesn't spell Harry Potter with an R, with 3 R's instead of 2, right? Because then the searches wouldn't be right. So we do want to make a job table that links into this. Now, then you have the question, well, that wouldn't really be, the question would be, in some cases, would one person have more than one job designation, which I don't think would happen in this case. So there's that. So the job table. And you know what? We would do, how would we do this? We could do an age range table. Because Legos have an age range. Or, oh, no. How about difficulty?
Difficulty? Okay.
Yeah, because I haven't seen a Lego set in a while, but I think it has a difficulty level.
Yeah.
Right?
It has, yeah.
Yeah, so you have the difficulty, and that would be another table, and you'd have like a difficulty ID here. And do it that way. Okay, so I think that'll work. Yeah, I think that'll work. So if you create these 4 tables, right, and then link them into here. And yeah, you have your 12 tables. So then once that's done, and once you have that, you need to write your create statements for all 12 tables. Okay. And then you need to start writing queries. You need to write some SQL statements that insert, update, and delete the data in the tables.
Okay.
So you want to write a query that's going to insert a customer, write the query that's going to insert the employee. Now remember, keep in mind here, when you insert, since you're foreign key the zip code, you need to populate the zip code table first, and then you can populate employee and customer. Okay. Whenever you're foreign keying something, the table that is the primary key to their foreign key has to be populated first before you can do anything else. So zip, category, and payment need to all be lost my train of thought. Like populate it first. So you need to write a query that populates customer, employee, populates zip code. So each table should have at least one statement that populates it. Okay.
Oh, okay.
Yeah. And then update, like updating customer information. Customer phone number change, employee phone number change. Think of any columns you might want to add to this. You want to do date of hire on the employees table to see their work anniversaries. And then you need something that's going to put into the orders table. And then you might want then when you get all that stuff done, you might want to write some queries like write some queries. You have to write some queries. You have to actually insert data into the tables. So these queries you're writing, you need to insert some data into the tables. And then write some queries like like things you were asking, like how many of a specific category have been sold. How many Lego sets have been sold in a specific zip code. How many Lego sets have been, how many Harry Potter Lego sets have been sold, and what states do they go to? Kind of like that. If you need help with that, I can give you some of those. But just kind of like a work. Look at what you're creating this called case scenarios or case studies, right? Like what would have to happen with these tables. Okay. But yeah, so that's pretty much it there.
So I do have. I wanted to ask you.
Sure.
With the shipper and the order shipped, where does that connect in? Is that to the weight, or is that?
So the shipper would be a table by itself, right? And the order ship would foreign key. So the shipper table would have like shipper ID, shipper name, shipper address, shipper phone number, stuff like that. And the order shipped table would have the order ID, the shipper ID, the weight, and probably here you'd have total.
Oh, the total amount.
Yeah, total amount. That would be there, right? Because that would fall there. And then the shipper order ship table. So order ship would be order ID, shipper ID, shipping price, date shipped, date received, tracking number. That's what I can think of there.
Okay. So the order shipped, that's how the shipper is connected to the rest of it.
Yep.
Because it'll have order ID, primary or foreign keying too.
Yep. So your shipper table. So you have the order ship table, and that'll foreign key to orders, and it'll foreign key to shipper, right?
Okay.
And then see that'd be the interesting thing, because when you start looking at that, and everything gets connected, all the tables get connected in some way. So you can literally find out how many people from Arkansas bought Star Wars Legos. I forgot this here order date. In February of 2021 and shipped it via UPS. You would never have to do that, but
it's possible.
It's possible. I mean, if you think when you think about how data is used, right? So let's say you've got this company, you're doing this great. You want to see, like, we use UPS, we use FedEx, we use Post Office, we use DHL, and we use, those are the four that we use. Let's compare to see which ones gets used more. What do our customers prefer? And let's get rid of the other ones, right? So you can write a query to see how many orders were shipped via DHL, UPS, and find out like which one. You're only gonna keep the top two, right? So, yeah, this says that. So in the job table, which it'll be like the category table, just attach employee, and like the job ID would be there, and the difficulty table. And again, if you want to change any of these tables, think of something else, go ahead and do it. Difficulty table attached to the product table. On how difficult it is, like beginner, intermediate. How many intermediate sets do we have in stock? Oh, good grief. Quantity. Almost forgot that we needed the quantity we have in stock.
Oh, that's like the inventory stock.
Yeah. Yep. Because this is our stock, right? So anyway, so this is kind of like you kind of see, how this, and I'm glad we talked tonight so I could record this, which hopefully I did actually record, I think. I'm hoping. Yeah, I did. So this is the process you go through in designing a database. You just kind of go, here are the tables I need, and then kind of go, okay, how do I get these tables to connect? Where are my one-to-manys? Where are my many-to-manys? Where are my one-to-ones? And kind of get those, get those here, get those in there, and they create the tables. And it's like this kind of like flow charty thing that happens. And you just get this, I always say design it on paper first. Well, this is technically paper. And then do it in code. Because once you have it on paper like this, then doing it in code is easier because you know where everything's going to be.
Yeah.
And like here, I forgot we had the added quantity. It's a very important thing in products. We know how many we have of them. So yeah. So do you have any other questions on this? Anything else you want to talk about?
Well, it's more of a comment, but it
Sure.
reminds you of like, I guess, relational databases. It looks like electronical wiring
Oh yeah.
is
It looks like that because it looks like a plumbing diagram. It looks like electronics diagram because it's all a flow. When you think of database, you got to think about how the data flows, right? And electronics diagram is how the electric flows. How does this capacitor lead to this resistor, and how does the power get everywhere, right? This is just how does data get everywhere. And if you were to see them, like if you saw real ERD, which I think they were in the if you've seen a couple through the course, they look like electrical diagrams. You're absolutely correct. Anything that flows will have a similar diagram.
Oh, and then also, I wanted to ask about it's kind of like a side question, but MySQL, so that's like a free option for businesses to like use versus like
Yes.
Oracle or
But so it's a great question. So MySQL is a free option. Okay, there are some restrictions to it, like how big the database can be, how many people connect to it, and things like that. It's free. Like if you're doing like Azure or Amazon Web Service or anything like that, you can stand up a MySQL database for free, and there's no licensing cost to it. It is the free offering from Oracle. Microsoft has a free offering called SQL Express. That would also be a free offering, but yes, MySQL is the free offering from Oracle.
okay, so it's like a good option for like a small online business. So.
Sure, absolutely. The less small business have to pay, the better it is for them. Like even if like you were doing like a mail order business out of your garage, you don't want to pay a lot for the database, and you don't want to run it locally. You want to run it somewhere else. So you put it out there, and you don't pay for the database.
So a lot of these are done. I don't know. it's done like remotely. Then you're not actually having a server. It's
It's that it depends. It really depends because you never know. Let's do this. Okay. It depends because if you're a larger company, if you have a it depends on where you're hosting your website. If you're hosting your website yourself, you can totally do that, right? It just depends on what you want to do. You can buy a server. You can buy a big computer, put it in your garage, and you can host websites in your house, and you can put the database on that computer. More and more people lean towards cloud because of the scalability of it, and you don't have to buy a big computer, and it's way cheaper, but it's not as secure. Right?
Oh, that's the downside.
Yeah. Anything's on the cloud. I mean, believe me, I'm not saying the cloud is not a secure place to put stuff, but the difference is I've got the data out in a share in the cloud where it's kind of open. There are firewalls to protect it, but someone get in, or I could I've got a computer in my room where I can turn it off and unplug it. So there's concerns. There's no right answer to this. It depends on what your business needs, what your business can afford, and what makes the most sense for it. Buying a computer and hosting websites and everything else can get very expensive. You can run a database on Amazon Web Services using MySQL for like pennies a day.
Oh.
Okay, so but if you're like, let's say you take a different, like you're a doctor's office, right? And you don't have a secure, because law states that you must keep that data secure. So you might want to keep that local in your office because it's more secure if you keep it in your office, right? Because of HIPAA laws. So it all depends.
That's true.
There's no one fit, and the trick is kind of like having a general idea of what can be done across the board, so you can suggest things.
Okay.
But yeah.
Yeah, I guess I also wanted to ask about subqueries because I'm kind of confused with, because I know there's different ones. There's non-correlated. There's correlated.
Well, let's
Oh,
just
okay.
let's not talk about that. Let's just talk about what a
Oh,
subquery is,
okay.
okay? So, let's do select. Let's do it from the actor table, right? Let's do select actor as a first name. Let's do this. Let's do the film table. I think. Okay. We're gonna do select.
Did you switch the screen over, or is it?
Oh, I'm sorry, Anthony. You know what? I am. Let me stop sharing here because I was only
Oh,
sharing
okay.
the spreadsheet. I wasn't sharing
Oh,
everything.
okay.
So let me just do I'll be jumping around here for the next little bit. So I'll just go ahead and do this. You see it now? So I'm gonna do select title.
Yeah.
And I'll do select.
I think so.
Let's do select rating. Okay. From film. Film. Inner join. We're gonna join film actor. Now, I'll preface all this with the statement that you are never supposed to live code while you're working with somebody. So I'm breaking rules here, but I'm gonna do it anyway. FA, and call this F, and then F dot, and then F dot. Okay, and then we're gonna do this on F dot film ID. Okay, film ID equals film ID. Okay. Equals FA dot film ID, inner join, actor as A on A dot actor ID equals FA dot actor ID.
Yeah, I think my screen it crashed for some reason. Like I could see the small like yeah, I can see your camera, but I can't see your screen
Screen?
share for some reason.
Let me try again.
Yeah,
Let's
it
try.
like black. I don't know.
Okay, let me try my
It
screen.
said
Let's
it
try.
crashed.
Did you see it now? I reshared it. Did you see it now?
Okay, I can see it now.
Okay. So I ran this query here and I got this results, right? So I'm going to go here and I'm going to say where A dot last name like D. Okay. And then I'm going to go up here real quick and add A dot last name. Okay. So if I run this query, I get all the movies and the ratings for every with the actor's last name begins with a D. Okay. Now another way to do this is get rid of this here, and in here do this. Select last name. Let's see. Select actor ID, comma last name from actor, where last name like. Okay. Now if I did this right and run it, it gives us the exact same results. Okay. So what subqueries are ways to generate data sets that aren't necessarily in tables. Okay. Let me see if I can make that a better example of that.
Okay, so it's kind of like how joins they create a new table. Oh, but it's less. It's more abstract than that.
Right,
It's
right,
more,
right. See, when you're doing a join with a table, let's see. Let's do this a little differently. Let me change this back to actor here. Right, I'll show you. So I want to write a query that's select film select name. Where's film? Okay, so I'm gonna do it. Select title and rating from film. Inner join film category. Well, this is gonna get complicated. Let's see if this might go belly up here in a second because I'm messing around with things, but let's see what happens.
Okay.
I may be making it just a little too complicated. Okay. Okay, let's just run this and see if we get results. We do not get results. No title and field list, so f.title, f.rating. Okay. It'd help if I spell title right. Okay, that should be better now.
Okay.
Okay, that's that, right? Okay. So then what I'm going to do is I'm going to take this, right? And I'm going to do this. And hopefully this will work. Okay, now, what I've done here is I've replaced the film table with this query. Okay, so now if I run this, I should get results. Nope. Oh, oops, okay. That was my bad. You see, I forgot to put the film ID in the select clause here in the subquery, and that's what broke it. Okay. This should be working now.
So do you usually need to include the ID then?
I had to because I'm joining it here. Because I wrote this join, I replaced the film table with this query, and I was joining on film ID, and I had to have it in there for it to work. Okay?
That's like,
So now I got this whole bizarre convoluted thing here. So when you use a subquery, the subquery is being used to generate a set of data, okay, that isn't necessarily native to the database or to any one table, but you need it for your specific query.
okay.
Okay? Does that make sense?
It's like, okay, because it's like another qualifier within.
Right. Remember, it's all about how you're presenting the data, right? So you've got to present it. So when you present the data out, you're massaging it to make it look like what the customer needs. Okay. Sometimes the data you need to manipulate isn't in a table by itself, and you don't want to put it in a table by itself because it's a weird one-off, right? So, but that's what it is. So don't worry about this. Whatever the words I forgot the words you use, but just understand this about subqueries. Subqueries are used to generate a set of data to manipulate in a main query that doesn't necessarily exist in a native form in the database. Which I'm not sure is less complicated or not, but I think it's a little less complicated that way.
It's a little bit less because you're not using like terms like correlated.
Yeah. Don't worry about correlated, not correlated. Those are literally terms that you use in class and not in the world.
Okay. Okay.
When
So
you're writing query, go ahead.
So it's non-native data that you're trying to generate.
Right. It's data in. It's not in its natural state. I don't have this information in a table. and I don't want to make a table for it because it's not used enough to warrant me making a separate table for it. So I can write a subquery to get that where I need it to be. Subqueries, the downside to subqueries, they cost a lot more as far as resources.
Oh, okay.
Because you're running, well, and I forget how many down you can nest. You can nest, there's a limit to how many subqueries you can nest in queries. Because you can go down like, nest. So I
It's
think
kind of
there's,
like Big O or something. I don't know if
yeah,
that's
yeah.
used.
So when you run this query, it costs double. When you run a regular query, it costs X amount. When you run a subquery, it costs X squared with the resources, right? Meaning if it used like, just for ridiculous, if you used like 1 gig of RAM, it used 2 megs of RAM to run the query, right? To run the nested query is going to cost you 4.
Oh, okay.
Which doesn't seem like a big deal until you
Right.
realize that transaction is be running 10,000 times a second.
So
Right?
it's like it went up by four
Yeah,
times.
it was squared. Those aren't like the true numbers, but I'm just giving you an example. Every time you run a query, it costs resources, right?
Okay.
And a query is never just run once a day. It's run several thousand times a minute, an hour, a second. So let's say this query, like a simple query, costs 2 megs of RAM to run, right? But it's run 10,000 times a minute. So that's 20,000 megs of RAM that are used, which is like 20 gigs.
Oh, so it's
So that cost becomes substantial, right? But then if you add a subquery to it, that 20 gigs turns into 40 gigs.
yeah.
So you see how it kind of ramps up pretty quickly?
And then it's being run a lot too.
Yep. So you got to be careful how you use these things, right? Sometimes you have no choice but to use a subquery, right? Because you need to make sure that data is being presented the way you want, and there's no way to do it easily with the tables at hand.
Okay.
This could have been totally done without a subquery. I just use that for an example. But that's what it is. So learn the definition of correlated and non-correlated subqueries, and I honestly don't remember them offhand. But as far as like writing the query is concerned, this is why we do it.
Okay.
All right.
And
A lot of good questions tonight. Anything else?
yeah, I guess I do have a question about the project, or a couple of questions.
Sure.
I was wondering, is there like a rubric, or do you have
There
that posted
is.
somewhere?
There is,
Okay.
and it's in the link in week 3 on
Okay.
there. Yeah, let me see if I can find it real quick.
And then, are there subqueries on this project, or is it mainly just? Because I know there's the update or create, update, delete, right? The CRUD statements, and then I guess joins as well. What else? In
What do
theory,
you?
should I?
I'm not sure what you're asking.
I guess what I'm trying to ask is like, with the statements or the project thing,
Right.
how or which statements are required so far?
Okay, so I got the rubric up on the screen now. Hopefully you can see it.
Okay, so
Okay.
yeah, I can see it.
So it doesn't say how many CRUD, which is create, update, delete. I forgot what the R stands for. But basically, you need to write test cases. And so you need to write you create your ID, right? And the queries and the statements to create the tables. That's part 1, right? Part 2 is you need to write the CRUD operations, which will be like, inserting into your tables, right? You should have at least one insert for every table, one update for every table, and one delete for every table.
Oh, okay.
Okay. The test cases are going to be like, we propose that this is the process for when say the test going to be like, we will want to track how many users from a specific state purchase our products. We want to track how many sales we had on December 25th. We want to track, like I said, like how many people, how many times each shipping service is used. Okay.
Okay, so it's more real world.
Yeah.
Or
And then so when you write the test case, then you write the query that goes with it.
okay, so the joins could possibly be there, but it could be subqueries. It could be.
And so don't worry about it. If you need a sub, you probably won't need subqueries for this. As a matter of fact, I would strongly advise
Oh,
you
okay.
to just
Not to use
write the
it.
state queries. Don't worry about the subqueries, right? And just write them like, follow the flow of the data and how you'd write the query.
Oh, okay.
So
So
come up with a possible test case. I need I need to be able to see how many people in Logan, Utah purchased Star Wars Lego sets and had them shipped via UPS.
okay.
Okay. That's a ridiculous one. Don't do that one. But like, we want to track how much time each shipping company is. We want to track, you know, how many people have bought difficult Lego sets from, in this age range or something like that. Because you can like get their age from their birthday, right?
Okay.
How many, which employees have sold the most Star Wars sets? Which employee, so you can, that's kind of what you need to do.
So
So
okay.
you'll need at least 7 test cases.
7 test cases.
Yeah. And you'll need, my humble opinion, if you've got 12 tables, you'll need at least 36 CRUD operations. Because you want to insert, update, and delete for all 3.
Okay, and then another one that I have a question on is, so for the data I'd have to like make up
Yep.
some hypothetical. Oh, okay,
Yep.
okay.
You have to make every insert's got to be made up stuff, man, because you don't own a Lego shop. Unless you do, and that's
Okay.
awesome. I'll buy from you.
Okay. Yeah. Yeah, I don't own one. Okay, so it's like 7 different test cases.
Yep. At least 7.
At
If you're
least
feeling,
7.
yeah, if you go crazy and make more, and no one's gonna stop you, dude.
Yeah, but at least 7.
Yeah, because I know, well, like I'm just sitting here going, okay, here's a bunch of them. Like I can knock them off the top of my head, just for fun, because I have fun weird ways, because I like writing queries.
Yeah, yeah. That's good. I haven't gotten to that point where I like it. um,
It's kind of like, for me, I like the way the data flows, and I like seeing if I can get it to do what I want it to do.
okay.
And I would challenge myself with the most ridiculous queries. Like I would write a query for everyone who had an E in their last name from a state with R in the name of the state, who's over the age of 30, that bought Harry Potter Legos on the 7th day of the month. Just something. I mean, you'd never need that. But I just like, let's see, and I'd write
Okay.
this like ridiculous query just to see if it would work. But no one would ever want that query. No one would ever care that much, unless it was some kind of weird trivia question. But it's not like, how many, which is our best-selling Lego brand, which is our best-selling Lego category. That would be a very valid test case. Which employee sold the most. Which employee, in other words, which employee brought in the most money. right? So you get the total of all the orders that they've been responsible for selling.
Okay, so it's
Yeah.
like
What
with
day of the week
database.
is it? No, go ahead.
Oh,
No, go ahead.
it's like you can find out like if something is efficient, or you can find out if I'm not sure exactly what like for example, which employees sound the best, or
Right. Like look over
what's the
here.
best.
Right. So let's look at the Sakilla database, right? What we've got in here. What kind of weird queries we could write. Like, here we got staff ID, and what does staff talk to? Rental. Okay, so we can find out like which, and like, so here's rental ID, customer return date, staff ID. So we can say like, and then let's go into the inventory table. Okay, film ID, and then film ID, we've got this, and then we got film category. So we can find like which employee rents the most horror movies with this.
Okay.
Like we can have like let's say like for the, like this is a video rental company, right? So we can have a contest for our employees. Whoever rents or sells the most horror movies in the month of October gets a Chick-fil-A gift card.
Okay.
So we could write that query off of here just by what's here. Because here's the staff ID. Staff connects to rental, which is here. So there's a rental ID and what was rented, right? So from the inventory, we go into the inventory. There's film ID. Film ID is right here in the films table, and then we got film category, which links to. So that whole thing will connect out. So for like July is Harry Potter's birthday month, so you might say we might have in July, we have a sales incentive for our employees to whoever sells the most Harry Potter sets in the month of July gets a free gift card. And you do a query to get that out to see which employee sold the most.
Okay, yeah.
Right? But once the ERD is done and you're kind of thinking like, you have to think in terms of like, I've got a business I'm running, what would I need to do? How would I need to do this? But yeah.
Okay, and it's due like the 27th, 28th of March.
It's due on week 13. So whatever that's,
Okay.
today is week, this is week 9, 10, 11, 12. Yeah, like it's due
27th.
9, 10, 11. Yeah, so the week of the 27th, I think is when it's due. The sooner you get it in, the better,
Yeah,
because
yeah. That's
it's a lot of work
you
to
don't
do.
want to wait.
Yep.
Okay. And also, I was gonna ask, because I like, because I've looked at IT for a little bit,
Uh,
but it seems like, for example, like people that write scripts, or I mean that they run like the what do you call it? They run the security or the PowerShell, not PowerShell, but they run the Windows configurations for versus like a software person versus like a database person. They all think very differently,
yes,
or their jobs are all very, yeah, it's very different.
they all require different parts of the brain. A PowerShell coder is similar to other coders because coding, you kind of use your right side. You're predominantly right-sided in coding with some left side because it needs some kind of structure, right? But coding is a lot of creative with a little bit of structure, right? Like administering Windows computer is a lot of structure with a little bit of creative. You don't get creative when you're building a computer. It's a structure. When you're running wires, you're running wires for an internet. When you're throwing wire for internet for access, there's not a whole lot of creative. You can be creative on the colors of the wire, but they've got to go a specific way, right? So yeah, they're all in a different mindset. They don't really work. It's hard to do. It's hard to be a coder and a like admin.
Okay. But I would say that like coding is probably the least, at least in my opinion, I feel like it's the least creative. But maybe because I feel like database is more
Well,
creative
remember
than.
in coding, coding, you're like, let's say you're coding a game and trying to figure out how to do something. You know, there are rules. Creativity is bound by rules, but that doesn't limit the creativity. Because you're trying to program a game where, you know, whatever happens, you know, like I don't know, like Pokemon Go. If you're trying to create a game like that, you know, you got where the Pokemon pop up, how they're gonna be caught, their algorithms for like whether they're caught or not, and you know what they look like, and the ratios when things happen and when you get special things. So there's a lot of creativity to it, but it's not like in terms of I'm painting a picture of a pretty flower. It's like I'm writing code to make something happen. I'm literally bringing something to life with my code.
Okay.
It's a little more. It's a little different way of looking at it when you're looking at it that way. You see where the creativity lies. You know, I'm bringing things to life in my code.
Well, I guess maybe just like how they think about it is maybe one flows more than the other.
Yeah, I mean, there are people with any job. There's the people who like just do it to get by, and there are people who love it and do a great, amazing job of it. You know, you can absolutely code just to do it. You know, make your dollar and then go, but nothing. You don't do anything spectacular. You know. Look what they're doing. What is it? Microsoft announced that they're making AIs based on departed relatives. So that's got to be a serious bit of coding in there.
Oh yeah, I was gonna ask, is that why, for example, like Siri or Alexa, some of these AIs, is that why they run on databases? Because there's information and then there's kind of like path or like a flow.
Right. Well, everything runs on database because if there's no data, no one knows anything. Alexa's
Oh,
not.
okay.
Yeah. But let
Okay.
me. Yeah. But Alexa and Siri aren't AI.
They're not. Yeah, they're not true AI. They
Yeah.
just
They
called
can't
that.
think.
It's like a.
Yeah. They can't. They're assistants. They don't. They. It, God help us if Siri, Alexa, or Siri start thinking for themselves, which would be very, very bad for everybody. That's how Skynet started. But
Okay.
but uh, uh, but yeah. So yeah, everything runs on data. Alexa can't exist without data because Alexa has is locked into your database on in Amazon. Everything you've bought, everything you've purchased, all your settings, everything is there, and it's connected to that. And if it loses that, it doesn't know you, and it can't do anything.
Okay.
All right, buddy, we are zoning in here on almost hour and 45 minutes, so let's go ahead
Okay.
and
Yeah.
kill it here. Okay.
Yeah. That sounds good.
If you have any more questions, let me know.
Okay. Thank you.
Bye bye.